Good morning, everyone. Hope all is well. Hope everything's going all right. As always, want to give everybody a chance to get in before we get rolling. All right. Today, I know last class we covered 1.2. So today we'll be looking to get into 1.3. Okay. Yeah. All right. So everybody good? Everybody straight? Like everybody in here? Okay. So I believe this was the class I had one question I know I need to address before we leave. Just a problem that someone was trying. So if anybody else have any other ones, we'll most definitely knock those out before we leave. So let's go ahead and take care of 1.3 though first. All right, so of course, here we go. 1.3 is our models and applications. So I know it's everyone's favorite section, word problems. All right, so there's having issues and lessons. All right, so we have a strategy here, 5-step strategy. First, you want to read the problem. Of course, read the problem as many times as it takes to make sure you have an understanding of what's going on and what's being asked of you, if necessary. And I put an asterisk beside steps 2 and step 3. So, because that's where a lot of people, may get hung up in or hung up at. If necessary, write each unknown in terms of one variable. And what it means by that is that what we do not want to do in these type of problems that we have is, if we have multiple unknowns, right? One is X, the other one Y, another one Z, and so on. Because the more variables you introduce, the more equations you may need to be able to solve. And then you have to deal with a system of equations versus just one equation. And we don't want to do that if we don't have to. And we most definitely don't have to do that in this section. So we're going to write all of our unknowns in terms of one variable. So we'll see how we'll do that. Then we'll write the equation based on the words that are in the problem. From there, we'll solve and then we'll check. Make sure we actually answer the question. All right. So as always, if I scroll up and you're still writing, feel free to type in the chat or unmute and let me know. And if you have a problem with anything I've written, feel free to let me know as well so I can bring clarity. So first problem, the average yearly salary of a man with a bachelor's degree. I tried to shorthand some of this. With a bachelor's degree exceeds that of a man with an associate's degree by $25,000. The average yearly salary of a man with a master's degree exceeds that of a man with an associate's degree by $45,000. Combined, they earn $214,000. Find the yearly salary of each. Okay, so I'll give you guys a chance to write that down for those who are going to write it. Right. Okay.
In that combined portion, are they
Mhm.
talking about all three of them?
Yeah, we're gonna make sure we bring clarity to that. But yeah, they're talking about all three of them.
Okay, so the bachelors, the masters, and the associates.
I see somebody throwing some numbers up there. We'll see. We'll see. All right. So let's scroll up a little bit. So I'm not going to erase the stuff, but we'll just talk through it. So we have three different unknowns here. We have the associates, person with an associate's, person with a bachelor's, and a person with a master's. So you need an algebraic representation for all three unknowns in order to be able to progress throughout the problem. But what you do not want to do is what I was mentioning earlier, that you don't want to call one X, the other one Y, and the other one Z. So if you go back to the wording, the first sentence says that the man with the bachelor's exceeds that of the man with an associate. So the man with the bachelor's is described in terms of the man with an associate's. So, a man with a bachelor's is described in terms of the man with the associates. And then we look at the man with the master's, he's described in terms of the man with the associates as well. So what we can do is call the man with the associates X and then describe the other two in terms of that X. So the man with the bachelor's exceeds that of a man with associates by 25. So that means if a man with associates makes X, add 25 to it, that's how much the man with the bachelor's makes. And then the man with the master's makes 45,000 more or exceeds that man with the bachelor's associates by 45. So that's why that will be X plus 45. So here are our algebraic representations of each individually: X plus 25, X plus 45. All right. So then step three, like your classmate just mentioned, combined is the key word here. So combined, or in other words, when you add all three together, they will equal out to 214,000. And so that's what we did right here in green. Add all three together, we get 214. Now I put parentheses around each one of the three just to signify or group together what was added together. So X plus 25 plus X plus 45. But the grouping symbols don't do anything for us. All we're gonna do is just combine the like terms in the next step. But before we go to the next step, is everybody okay with steps 2 and 3? All right. So now combining your like terms, going to step 4, we're going to solve in the blue. X plus X plus X is 3X. And then 25 plus 45 is 70. Now we can continue our solving process by subtracting 70 from both sides. So I don't know if you guys saw in the chat, your classmate was correct that 3X plus 70 equal to 214. And then divide both sides by 3, X is equal to 48. So make sure we're okay with that 48 before we finish off the problem.
Are these real numbers? Because I wish I made $48,000 a year.
Maybe in another state.
Yeah, or another planet.
Could be that too. Another dimension, right? The state of inflation. That's good. But yeah, whenever I saw these numbers, I always think the same thing. I'm like, wow, that would actually be some good numbers. So remember, they ask us now. Remember, you're supposed to check and more, it goes more into just saying, okay, is this the right answer? Is have I actually answered the question? So remember, it tells us to find the salary of each. All right. So X is 48, and then plug in 48 to the bachelor's. 48 plus 25 is 73, and then 48 plus 45 is 93. So those are your three values in orange: 48, 73, 93. And also, you can add those together to see if they give you 214. They should give you 214 as well. All right. Any questions on that first one?
I have a question. Where did you get the 3x plus 789?
Right here, we combine the like terms. X plus X plus X gives us 3X. And then 25 plus 45 gives that 70.
Okay.
Mhm. All right. Anybody else before we scroll up? All right. So the next one, your local computer store is having a sale on cameras. Could have wrote that. That's better. Probably could have wrote a lot of this better. On cameras, after a 40% price reduction, you purchase a camera for $276. What was the camera's price before the price reduction?
Um,
Mhm.
when they say 40% price reduction,
Mhm.
do they mean that it was reduced down to 40% or reduced by 40%?
By 40%.
Freaking decimals.
I knew you guys would love word problems. I just knew it. All right. So
Except no.
so when you're talking about retail, whether you work retail or not, there's always this thought process that should be, I won't say evident, but it's the only way to get there. In other words, what I mean by that is that you have an original price, you're going to subtract the price reduction, and that gives you your sale price. Like that's the only way to get there, right? So those are the three pieces that we need algebraic representations for. We need a representation for our original price, the price reduction, and then the sale price. Now, the one they give us is the sale price, that's 276. And then the original price, we can call that X because that's what we're looking for. That's our unknown. Now, that price reduction is where a lot of people make a mistake. So we want to be careful here. So we have X minus, notice what I did here is 40.40X equal to 276. So where do I get the 0.40X from? First of all, 40%, you do want to convert it to a decimal before you do your calculation. So you move your decimal 2 places to the left. So that's how we got 0.40. Now, whenever you're doing percentage of something. Very rarely do you have a situation where your percentage will stand alone. So we have the 40% of something. Now, none of this existed before the original price. So you couldn't take the 40% of the sale price. So that's where a lot of people make a mistake. They'll do 0.40 times the 276. But that means you did 40% of the sale price, which was really impossible if you look at the process. So really what you had to do was do 40% of the original amount. You have your original amount, then you take 40% of the original amount and then subtract that, that will give you your sale price. So that's what this represents right here. 40% of mathematically means multiplication. So this 40% times the original amount. Our original amount is X because we don't know it. So this 0.40X, and then that'll be equal to 276. So questions on that setup before we go to the next piece, next part of this.
No questions on the setup, questions on the solve though.
Okay. Do you want to go ahead and ask?
I'm just looking at it and I'm a little lost.
Okay, cool, not a problem. Yep,
Word
yep.
problems, not fun.
I'm so sorry. If I had a choice on what to give you, I would have gave you this one.
I mean, like, I thought we were done with word problems in like 5th grade.
Unfortunately not. So now we have to combine alike terms. We have to subtract. All right. So where a lot of people make a mistake here is that there's a 1 right here. So 1 minus 0.4 is going to be 0.6. And so, like your classmate just mentioned, this goes way back. You know, we talk about subtracting decimals. And so a lot of people forget that. That's why I went ahead and wrote it right here. So you do 1.0 minus 0.4. Most of the time we just throw that in the calculator, but I just want to make sure because I had people that ask, well, how does that happen? You know, because like I said, that's old stuff, old school stuff. So 1 minus a 0.4 will give you 0.6 right here. So after you have that 0.6x equal to 276, divide both sides by 0.6, and that'll give you 460. And that 460 represents your original amount. All right. All right, any problems with that one before we go to the next one? Just going through an array of examples, make sure we're good. Always remember when you, some of these questions you may not even have any questions until you actually start doing the stuff, but always remember that if you have a question, especially on word problems, to bring that problem to the table. In other words, coming to me and saying, hey, Mr. Tuck, I had a problem with word problem. What this word problem I was working on last night. I was like, okay, well, good. What was that one? And then you don't have it. I'm just like, well, I can pick 5 word problems and still not address the issue you had with that specific word problem. So, write it down, take a picture, do something so that we can make sure you're good with that one. Because it may just be one word that could be throwing you off, just stuff like that. So, especially when it comes to word problems, make sure you bring the one you were dealing with to the table. All right. I don't know why my stuff keeps disappearing. So now let's look at this one. Once again, let me know if you have any issues with how I wrote this stuff. Sometimes you get a little sloppy with writing all this stuff on the screen like this, but it says your grandmother needs help. She has $50,000 to invest. Part of this is to be invested in non-insured bonds, paying 15% annual interest. The rest of this money is to be invested in a government insured COD, paying 7% annual interest. She needs $6,000 in extra income from the investments. How much should be placed in each? All right, give you a chance to write that down.
There's 2 variables, aren't there?
There are 2 unknowns, but we still only want to stick to the one variable, the usage of just one variable.
But wouldn't you end up with 2 different amounts?
Well, yes. So we're gonna have a different amount that we would invest in the 15% than we would have in the 7%. So that's a good question. So what we're going to put in each account is not evident. So we cannot assume that's going to be half and half. What's going to dictate how much we put in each account is the fact that we want to get $6,000. You know, she want to get exactly $6,000 extra income out of this. So now what's going to help us to calculate that is, let me make sure everybody's done writing before I scroll down. Okay, for those I see. Okay, so don't write the red yet, write the blue. And we're gonna come back to the red. So the simple interest formula is what's gonna help us here. I equal to PRT, where I represents your interest earned. P is your principal, which is your deposit or loan. R is your rate, convert that to a decimal, and then T is your time, which is going to be in years. All right, yep, not a problem. Somebody needed me to scroll back up. Let me know how much you need it. And if that's too small, I can magnify it. Just giving people a chance to write the blue. Okay. If everybody's good with what I, seeing it this small, then I'll go ahead and keep going. So we need to establish for each account P, R, and T. The principal, how much we're going to deposit, or an algebraic representation for how much we're going to deposit, what the rate and the time is. So the key here is that when we look at P for each account, since we don't have a hint on how much to deposit each, it's not like they said do half and half or do 3/4 here, 1/4 here. What we would do is we call one of them X, and then the other one would be the total minus X. So it's 50,000 minus X. It doesn't matter which one you do it with. If I call the 7% X and then call it the 15%, 50,000 minus X, when you do your calculation, you do everything correctly, you'll still come out with the same two numbers. But you just have to call one of the principals X and the other one the total minus X. So in other words, if I had $10,000 altogether, I would do X and then 10,000 minus X when I set up my accounts. Okay. So the rate for the first was 15%. So don't forget to convert it to a decimal. Move your decimal 2 places to the left, 0.15. Same thing with the 7%, 0.07. And then in both cases, we're just dealing with 1 year. All right, give you guys a chance to copy it down.
So real quick, is this going to be two different equations or this all going to be in one?
No, we're gonna put it all together. Yep.
Okay.
Yep, that's our next step.
Okay.
Now, I will say it is two different formulas, but we're gonna put them together into one equation. Yep. All right, is everybody done with the black? No, that's what. And can I scroll past the blue? Everybody good, everybody good. All right, so here's what your classmate just alluded to, setting up our equation. So the way we are looking at this now, we have a total amount of interest that's going to be earned. Remember, that's our 6,000. And so we're going to take the interest earned from the 15% account, add it to the interest earned from the 7% account, and that's going to be our equation. All right, so like I mentioned here, total is 6,000 that we're trying to earn. Now, the interest earned in the 15% account is P times R times T. So we take those three pieces that we had, X times 0.15 times 1, and that simplifies to 0.15X. And then in the 7% account, once again, P times R times T, our P there was 50,000 minus X. And then we're going to do our rate, which is 0.07 times T, which is 1. So now to simplify that, go ahead and distribute that 0.07. You know, one is just, you know, one, but distribute 0.07, and that gives us 3,500 minus 0.07x. All right, so pause right there and make sure everybody's okay.
In the case of it not being one,
Mhm.
would 5,000x distribute to it as well?
Yeah, so what I would do is, let's say if it was 2, I will multiply 2 times that 0.07, which would be 0.14, and then distribute 0.14 to each one of them.
Gotcha.
Mhm.
I'm sorry, how? Oh, okay.
So you mean tell me I'm just that good? I just answered your question without even speaking? That's how I roll? Okay.
Yep.
I still see people copying, so I'm just
God, it's been a long time.
trust me, I understand. If I wasn't doing this like every semester, I trust me, it wouldn't be that efficient on my end either.
Damn, it's been like 8 years.
It's been like 18 for me.
18?
Ooh,
Um,
good luck,
I'm
bro.
I'm kind of lost. Where did the 3,500 come from?
50,000 times the 0.07.
Okay.
Yeah, because we had to distribute that into the parentheses. So that's why it's 0.07 in front of the X. It was also 0.07 times that 50,000 turns into 3,500.
Okay.
Mhm. All right. So let's go ahead and put it in this equation right here. Put those 3 pieces. And that's what I did in the green. And I don't need those parentheses, but I just did that just to make sure we understood where our pieces came from. So we have 6,000 equal to 0.15x plus that 3,500 minus 0.07x. So like I said, really, these parentheses aren't needed. Like I said, I just did that just to make sure we knew where each piece came from. All right, so from there, we would combine our like terms. So that's 0.15x minus 0.07x. That'll give us 0.08x. You know, we subtract those two. Then subtract 3,500 from both sides. And that will give us 2,500 equal to 0.08x. And divide by the 0.08. And that gives us 31,250. All right, so before we finish off the problem, any questions up to this point? Make sure we're okay.
That's still not our answer, though. We found X, but we didn't find the total for both investments, so we still have to subtract, right?
You got it.
Okay.
We have
Okay.
one of them.
Say that again. Somebody said something.
So it's 31,250 and 18,750.
You got it. So there we go in the blue. So like she mentioned, 31,250 is our X that was assigned to the 15% account. Then subtract that from 50,000, and that will be what's in our 7%, which is 18,750. So now remember, I said that you could have called, reversed it, could have called the 7% X and the 15% 50,000 minus X. So what would have happened is you would have got these answers in reverse order. You would have got 18,750 first, and then when you subtract that from 50,000, you would have got the 31,250. So either way, you'll get the same two numbers, but if you do everything correctly, you'll still come up You just do, find them in different order. All right, any questions, any questions? Make sure. And some of the stuff, once again, you just may have to try it out to see if you actually have legitimate questions on it. You get in there. No, that's pretty much going to be the most involved one. Somebody said, please don't tell me that it gets harder than this, but that one's pretty much going to be the most involved one. But that's why I went through it, because I know you probably see it at least once in your homework. So make sure you guys are good. No, it didn't matter which one you had the 50,000. As long as one of them you call X and the other one you call 50,000 minus X, you still would have came out with the same two numbers. As long as you use this setup though, and then follow, the P times R times T thing. Yeah, you still get the same answers. All right. Now we good to go. Scroll up to the next one. This one's a little lighter. So we have the length of American football field is 200 feet more than the width. If the perimeter of the field is 1,040 feet, what are the dimensions? All right, so we're looking at the perimeter of the football field. And don't forget the football field is rectangular. All right, so the perimeter of a rectangle, P equal to 2L plus 2W. So if we're going to use that formula, then we're going to need an algebraic representation for the P, L, and the W. All right, so that's it. Yep, that's going to be one of your pieces. Yep. So you would call W X and then call L X plus W, because remember the length is 200 feet more than the width. So that's what we have established right here. X plus 200. And then the perimeter is 10,000. I said 10,000, 1,040. Once you have those three pieces established, you can go ahead and plug them into your formula. That's what I did right here. So it's 1,040 for P, and that's 2 times X plus 200 for L, and then 2 times X for that W. All right, so from there we can combine the like terms. 2X plus 2X gives us 4X plus 400 on the right. Then from there, subtract the 400. And then that will give us 640 equal to 4X, and then divide both sides by that 4. And X is 160. And then once again, once we get our value, our X, we do have to make sure we actually answer the question. So we go back, we recognize that they want us to give the dimensions. So we need the width and the length. So X represents our width, that's 160. And then 160 plus 200 will give us our length, which is 360. All right. Questions? Any questions? Make sure we're all right. All right. So let me see. Was anybody writing? Are we good to scroll up to the next one? Thank you. Okay. Mr. Williams said no. It's all right, man. We're gonna get it. Now, what I always do warn people, I like to warn people, make sure you're fair to yourself. You know what I mean? If you're seeing this for the first time or seeing this for the first time in a long time, give yourself a chance to digest or process what just happened to you. You know what I mean? You gotta give yourself a chance. Um,
Is like I don't get the process because like every time I look up, you're like scrolling down, so I don't even get to see you like work the problem. I just look up and see a bunch of different new symbols pointing in different directions. I'm like, oh, cool, awesome. I didn't see any of that, but awesome.
well, just know that if you have any questions, I'm here for you, man.
Oh, don't worry, we're gonna be talking soon, bro.
Let's see. Let's see what's up here. 1040. Total what we measured.
And look, this is my second time trying to take this class. I tried to take it as an 8-week course, and that did
Mhm.
not go so well.
Oh wow. Oh wow. Well, well, we're gonna help you get through it. We'll get through it this time for sure. For sure. You know, most
This
definitely.
needs to be a 2 semester course.
Well, see, unfortunately, the second semester they hit you with pre-calc too. So
But pre-cal 2 is all about like sine and cosine, because I took it in high school.
So it's the second part of the sequence, and you actually use the same book. I think I told this class, I may not have, but you actually use the same book. This class ends at chapter 4, and pre-calc 2 starts with chapter 5. So yeah. If I didn't tell you guys, make sure that you do not purchase another math lab code, because you should be able to use the same one for next session, because we're using the same book. So you should be able to use that same code for that book twice.
Do you teach pre-cal 2 as well?
Yep. I teach it all, man. I go from developmental math up to Calc 3, and it's just all about availability and what they want
There's a
from
Cal
you.
3?
Oh yeah. It goes all the way up to differential equations, ODE, PDE, just a whole bunch numerical analysis. Yeah, it can get up there.
I'm changing my major.
I won't make the mistake of taking calc at 9:30 in the morning next time.
But trust me, the worst is to try to take it at 8 o'clock in the morning. I'm not a morning person, and but I gotta feed my kids, so so, so yeah, they put me in a rock in a hard place.
Shit.
Yeah, man. Hey, I gotta know all this stuff, so I try to make myself as marketable as possible. There are some instructors that they only teach certain maths, but I was like, since I got to be here, I might as well. I mean, it is what it is. Just tell me what you want from me, so I just teach it all, man.
My last instructor was this like Asian guy, and I
Mhm.
could hardly understand him, and he was talking so fast and so smart. I was like, I'm good at math, and I don't understand what you're saying to me. So.
Now it may be because I know some people and that's why they don't do the lower maths, because some people can get so high up there that it's hard for them for you to not understand. They don't understand why you don't understand. You know what I mean? And
Yeah.
it reminds me of Jordan. They had this one guy was interviewing Jordan, Michael Jordan, for those who may be too young for him, I don't know. And so he was saying, it was like, Mike, how do you, do what you do? And he said that, well, Jordan said, well, what I do is I jump in the air and I hang in the air and I wait for the other guy to come down, and then I shoot the ball. And then the guy was like, well, Jordan, you do understand that most people cannot do that. But Jordan said it like, all you do is just jump in the air, hang there for a second, wait for the other guy to come down, and then shoot the ball. And that's his thought process. You know what I mean? Like, and so when he went to the Wizards, that was part of the reason why the Wizards didn't work out too well, because he was on them guys and he didn't understand. Look, no, do this. And so it's like that in math too. Like some people get so high up, they just don't understand why you don't understand. You know what I mean?
Well, not everyone's like 8 feet tall.
So yeah. Oh yeah, I most definitely saw The Last Dance. I still have
Who
a
was my teacher before
Mhm.
Mr. Tucker? I would have to go and take a look at that. Let me see.
Now, look, I'm not throwing any colleagues under the bus or anything. I'm just saying that, sometimes there is a disconnect, and that's why, why they would rather not teach them lower math and stuff. So yeah.
Hey,
Because I actually had one teacher back at Norfolk State. A student came to me and said, well, it was just about adding, subtracting like terms. And he told her she was wrong and she was actually right. And it was just adding signed numbers. But that was way down there from what he's up there with the count three stuff. So he easily could have missed it. So, it is, you do put yourself on the chopper block a little bit if you're not used to going up and down, back and forth between these different maths. So yeah, but we'll be here all day talking about concepts and stuff. So let's go ahead and knock this stuff out and get out of here. So solving for a specified variable. This is the next thing in this section, last thing that you talk about. So solving for a specified variable. You're not looking for a solid answer. So last time we got x equal to 160. This time you could have x equal to like an expression, not necessarily a solid number. So, but your goal is to get that variable that they asked for by itself. So when we look at this one right here, going back to our perimeter formula for the rectangle, we have P equal to 2L plus 2W, and we want to solve it for L. Do not forget that these letters represent numbers. So you want to treat them the same way. So over here, I have 7 equal to 2L plus 5. If I wanted to solve for L, excuse me, the first thing I would do is minus 5 from both sides. So I treat these letters the same way I treat the numbers. So notice my first move here is to subtract 2W from both sides. Okay, same process, just that they're letters instead of numbers. But those letters, once again, do represent numbers. All right, I'm not calling no names, not calling no names. So,
You already knew.
so in this next part of the process, we have P minus 2W equal to 2L. Don't forget, P and 2W are not like terms, so you cannot combine them any further than that. And then for the next step, so for the next step, you go ahead and divide by 2. Delete that over there. Divide by 2, and we're looking at L equal to P minus 2W over 2. So now this right here, we can stop right here as far as your answer is concerned, and I'll show you why. And I'll tell you what you cannot do in the next step. But I just wanted to make sure that everybody's okay with that. He says, crazy smart, just can keep up. Yeah, I'm telling you, man, some people can get to going. That's why I even tell you, like, if I scroll up too fast or whatever, let me know. Because, you can get to going and getting in your flow and mess around. I'm on page 3, you guys still trying to copy page 1. But
Well, I was like, okay, I've already taken pre-cal 1 and 2
mhm.
my senior year of high school, but I was like, I'm gonna retake it because it's been a while and college math is at a different level, but I'll take the 8-week class. It'll be fine. It was not fine.
It was not fun.
It was not fine.
Oh man. And yeah, so yeah, 16 versus 8 weeks. I'm telling you, yeah, it does make a difference. It does make a difference. So where a lot of people like to make a mistake here is they want to cancel out that 2. So you cannot just cancel out the 2 and then have P minus W as your answer. So that is the incorrect way to do it. Now, if you do want to keep going further, the way you would do it, I think we've done a problem like this before when we had this scenario. You have something in your denominator, it has to be applied to each term in your numerator. So the 2 would go into the P and it would go into the 2W. And so this is the correct way to try to reduce this further. That will give you P over 2 minus 2W over 2. And that would be P over 2 minus W because those 2's would cancel. But notice that 2 is still there. It's still represented under that P. And that's because it couldn't cancel out into the P. And that is why we could have left this right here, because the 2 doesn't cancel out completely. All right. Now, scenario in which you are expected to reduce is over here in the green. Now, this is just a random example. Does not have to do with what we just did. I'm just saying if there was a 4 in front of the P, or if there was a number that the 2 could divide evenly into in front of the P, then you would be expected to do that. So in other words, take the 2 into the 4P, take the 2 into the 2W, and that gives you this scenario. Divide the 2 and the 4 gives you with 2P, and then 2's cancel, give you W, and that will be your most simplified answer. So now, once again, you only do this if the 2 can divide evenly into each one of the numbers that are in your numerator. If not, you can leave it like this, and you don't have to go any further. All right. Make sure we are okay. I still see writing, so see a thumbs up. Miss Corporon, am I saying that right? Corporon? Did you see your mistake in that problem you sent me? You had one mistake.
So I actually was able to figure it out, but now
Okay.
I'm stuck on a different one.
Okay.
Um,
Okay. Okay, cool.
yeah,
So
math is just not my strong suit, and it takes me a while to process information.
right,
So I
right.
have to repeat things a lot and fully understand every single step and why it's that way, how it works in order for me to grasp information. So I'm a slow worker. Bear with me.
It's not a problem at all. Not a problem. I just want to make sure, because I know I saw your problem. I was like, oh, she had that one step. Other than that, everything was good. So, yeah. All right, so I think we got 2 more just to make sure we are good. Yep, 2 more, and we'll be done with 1.3. So here we have A equal to P plus PRT, and we want to solve for P. Bring that T over. All right, so notice we have P in 2 different terms, but we want to solve for a single P. And whenever you have that type of scenario, what you want to do is factor out that variable that you're looking to solve for. So that's what we did here. We pulled P to the outside, and that left us with 1 plus RT in the parentheses. So don't forget factoring is the reversal or the undoing of multiplication. So if you do want to check, you can always multiply that back into the parentheses, and you should get what you originally had. P times 1 is P times RT is PRT. So all we did was we pulled out or factored out P from those 2 terms. All right.
Can I ask something? Why did you pull out P? Like, cause okay. Sorry if I'm sounding a bit confused here.
Wait, you're fine.
But isn't like in the original creation thing, there's 2 P's technically. And in there, if you factor it, oh, I see now. I see. Never mind.
Okay. So y'all be making me feel good. I be answering questions, don't say nothing. I'm just looking at y'all, and then y'all just get it. But yeah, so just to make sure we're clear, for anybody else, we have 2 P's in this problem, but we want to solve for a single P. So when we factor out that P to a single P, now we're in a better position than we were originally. So I just want to throw that out there. Oh.
I got a question for you.
Okay, yes.
And right where you just circled the P that you factored, in the parentheses, that is 1 plus RT, right?
Yes.
Okay. Thank you.
Yep, not a problem. Yes, sir. And so yeah, somebody mentioned your mic is a little low. So if I'm talking and I don't hear you, always give me a chance to, you know what I'm saying, to get you or whatever, or type in the chat or whatever. Yeah. All right.
Is that better?
No, pretty much the same. Yeah. But yeah, we'll figure it out. But if not, like I said, if I'm talking and I don't hear you, just give me a chance to catch that you're trying to talk. And then we'll make sure you're straight. All right. So the next move, since we have P as a single P now we can divide both sides by that quantity of 1 plus RT. Somebody type it in the chat. Equal
Your
now.
plus sign and your T sign look similar. So I think people were thinking it's 1T RT. And that's why people were a little bit confused.
Gotcha. Yeah, I don't like it when they put the plus and the T in there because my handwriting is already not the greatest. So my penmanship isn't the greatest. So yeah, but it's 1 plus RT. Sorry about that, guys. All right, so now we divide by 1 plus RT. And we have P equal to A over 1 plus RT.
This looks like physics now.
Yes. Now this one right here though is actually goes back to our interest formula. You see how we have PRT? This is actually a future value of, and it plays off the simple interest formula, but physics starts to take on this same type of thought process and of having these different multiple variables and and all that stuff like that. So yeah.
Except there's Greek symbols that stand for numbers, which makes it that much worse.
Well, you know why that happens, because we ran out of letters. So we got letters in all these different places, and so we had to go Greek.
So they decided to use a whole different alphabet. I'm over it.
A stands for future value when it comes to your interest. So in other words, P is the amount you had originally, and then A represents what you originally had plus the interest. Because remember, PRT was our interest earned. So that's P plus your interest is your future value. How much would be in your account after T amount of years. All right. So everybody good with that one before we look at this last one?
So Brandon gets rid of nervous energy.
Just laugh it off, shake it off.
Smile till you make it, bro.
Oh yeah, oh yeah. So the next one, last one for today. Now that's funny. This is why I say we ran out of letters, because now we have A again, but this one represents surface area. So they had to go, this one most definitely is closer to physics than the last one. That was more finance. This one looks at, it's talking about area or surface area. That's a money in the chat. Somebody talk about your mic, man, and investments. So yeah, so
Hey,
we
got
have
kids to feed, they'll know.
Hey, I'm with you, man. The mic is the last thing on the list. So we have 2LW plus 2LH plus 2WH, and we want to solve for H. So whenever you have this type of situation, now we already talked about if we have multiple terms that have that same variable. So your goal should be to get all of your terms without that variable on one side, all of your terms with that variable on the same side. So we're going to minus 2LW. And that puts us into this position of A minus 2LW plus 2LH, not plus 2LH, equal to 2LH plus 2WH. All right. So now that we have H in two different terms, but they're all on the same side. Yep, somebody said factor. Yep, go ahead and factor out that H. Just like we did when we had that P that was in two different terms. Factor it out. In the parentheses, what we're left with is 2L plus 2W. Now we divide by that quantity of 2L plus 2W. And that's our answer. A minus 2LW over 2L plus 2W.
I was feeling confident Monday, but now you got my confidence all the way down.
Same. Oh my God.
Oh man, I'm sorry.
I was like, I got this. I remember it. Now I'm like, what in the heck is going on?
Well, on the bright side, it's only one section. Like I can't put. It's not like your whole test is going to be full of this. You know what I mean? So you get.
Oh my
So
gosh.
yeah. All right. So it says, well, test is in the future, not right now. Somebody, but I'm just saying that if you have a test, I can't put everything, from this section of a test. So there'll only be a couple problems. So it says since the division shares L and W in two. Well, because it's that plus and minus sign is here. We can't do anything with this with the simplification. That's all we got. Now, if there was a 2 in every single term, so in other words, let's say if it was 2A minus 2L over 2L 2W, then I can cancel out the 2 because the 2 is in every single term. But because it's not, then this is all I can do is just leave it the way it is. Yeah.
Would you mind going back up to the first one we did with the variables? I didn't get that one down. I'm sorry.
Okay, not a problem. I think everybody's done copying.
Let's go back to the simplicity of it all.
All right, you talking about right here, the initial problem, or you
No,
talking
no,
about?
no. All the way to the top.
All right, let me know when to stop.
There.
Okay. Now, when I look, I thought I saw that everybody was done copying. If not, I'll scroll back down. But while she's finishing that up, any questions on anything? Everybody good? Everybody straight? All right. So, like I said before, to actually understand what you don't understand, you got to get in there and try the stuff out. Some stuff you might even be able to figure it out by clicking on to help me solve this tools and all the stuff like that. And some things you still may not have a full understanding of it, even if you got the answer, right? So feel free to ask me whatever questions you want to ask. And we'll make sure everybody's straight to the best of my ability.
I got a question. What's the easiest way to look up the classes that you record?
All right, hold on one second. Let me throw you up a little bit. All right, you say what's the easiest way to do what now?
To watch the classes that you record?
I'm gonna send you. I'm gonna convert them to YouTube. Convert it to a YouTube link, and then I'm gonna send it to you in an email.
Okay.
And so you'll have access to it.
Because I wanted to clean my notes up from the other day. Because like I said, like I was just fast and furious writing, not really watching. So that's why I wanted to like watch it again so I could clean my notes up. That way it would help me actually study better.
Yeah, for sure. No problem. No problem. Yeah, I'll try my best case scenario. If I can knock them out like today, then I'll do it. But between today and Friday, you know how life works, man. Like if it's we good right now because my kids haven't woke up. Like really, they should be up by now, causing havoc. But so if they're not up, I can go ahead and make it for you guys and then go from there. But if not, between today and tomorrow, I'll get that to you guys. Let's see. Somebody saying something in the chat. What's going on in the chat? Great tissue. Somebody cookie dough.
I think everybody's finally coming out of their shell.
Right.
You mean I'm the only one crying during class? Oh my God.
Hey, I'm glad that somebody talked about the liquor because I was already thinking about a tequila sunrise.
Right.
No, it is 10 o'clock in the morning.
I need a
I'm
drink.
drinking at 10 o'clock.
Oh my God,
Oh,
it's too
man.
much.
Y'all are
It's
too
too early
funny.
for this.
Liquor and cookies, huh? And Disney Plus. All right.
There you go.
Oh, Keith's like 12.
You can make him a virgin drink. It's okay.
I got Monster.
Oh man.
Oh, this
Y'all
is
are
too
funny.
much.
Well, I'm sorry I'm causing so much havoc in your lives early in the morning. I do apologize. Oh, we got a 17-year-old too in here. Okay.
Wait, how old is everyone?
Well, I think I do have some high schoolers. I think that's what's going on here. I think I have some high schoolers. Wow, I got a 16. Okay. Somebody low-key freaking out. right. Okay, we got a wide range of people in here. So,
However old I need to be.
so while we tally up the age limit of the class right now, what can actually be done during class time? Any questions on anything before we close out? So we only gonna do 1-3 today. I didn't want to hit you guys with anything else. Even if we did have time, I didn't want to hit you guys with anything else but 1-3 today. Next class we'll look at 1-4. Ms. Dawn, did you still have that question, or you're waiting for another time?
No, I needed help on
Okay.
one of the problems.
Okay, so I'll
Not
look at
from today, from yesterday. I still need help with everything today.
right. So that's it for the lecture today. If you want to stay on and see what our problem looks like and see if that'll help you out, then that's fine. But if not, you feel free to go ahead and log off. And this class is only a Monday, Wednesday class, so that means I'll see you on Monday. Have a great weekend and be safe.
Is there only
Good
one
weekend.
homework assignment per unit?
Yeah, or per section.
Yeah, per
Yes.
section.
Yep. So
It
we
was
have
like
1, 2,
class and then one homework assignment.
Now there may be a time wherein like we're doing 1-4. I think that's lighter, so I may touch on some of 1-5. But as far as in math lab, it's just one homework per section. You see what I mean? So
Okay.
lecture, we may dip into another section or whatever. But when you go into math lab, that 1-4 only dealt with that 1-4 topic, then 1-5 only dealt with 1-5 topics, and so on.
Okay, then have a nice day.
All right, you have a good one.
Yeah.
I got a question. I got a question about last class that had a problem with for the front on the homework.
Okay. Yeah, I got Miss Dawn. I'm about to get her question first, and then I'll take care of yours.
Okay.
All right. If I can find some scratch paper. There's a review sheet long. I think this is my go-to. All right, this is way too long. Let me just add a page.
This OneNote program is cool. Do you have like an iPad in front of you or something?
Well, I'm doing the Surface Pro.
Oh, nice.
Yep, and
Gotta get one of those.
yeah, it's pretty cool. Before I had the Surface Pro, and I was trying to teach, now they couldn't write on the screen and stuff. Yeah, it was a hassle. It's a big time hassle. All right. So, what was your problem?
All right, so I'm stuck on number 9. I did everything how I thought I was supposed to do, but I'm getting the wrong answer somehow.
Okay. Can you read it off to me?
All right, so it's 2 over x plus 2 equals 3 over 4x plus 17 over 8.
All right, so I got caught up with my pen. It said 2 over x plus 2, and then you said
equals 3 over 4x plus 17 over 8.
Okay. All right, so that's exactly how you got it?
Well, that's the equation.
Yeah, that's what I'm saying. I wrote the equation correctly.
Yes.
Okay.
Oh, wait, where? I can't see. The screen disappeared, so I can't see your stuff anymore.
Let me see. Let me make sure.
Okay, I found it.
You good now?
It's really tiny. Yeah.
Okay.
Yeah.
Now, is it really tiny on my end because of me or something?
No, on my end, I can see it, but I can see it.
Okay, cool.
If you double click on his share screen, it'll make it big and all of us small.
It just eliminated everybody, but I can see the paper, so that's what counts.
So the first thing we want to do is find the LCD. So that's the smallest term possible that each one of these denominators can divide into evenly. So when you look at
So
X,
I put 8.
Yep, because when you look at the 4 and the 8, the smallest number that both of them can divide into evenly is the 8.
Wouldn't it be 8x?
Yes.
Yes.
Yes. All right. So now the next move is to multiply that 8x to each numerator.
Right. So I got 16 plus 16x equals 6 plus 17x.
So I'm going to just do it step by step for those who are watching. All right. So how you simplify, you can't simplify by multiplying and then dividing. But what I like to do is go ahead and divide it out.
What happened if 4x?
Did I leave a 4 out? Oh, you're right. Let the 4x off. Thank you. All right. And then the 4 goes into 8, leaves you with 2. This x cancels completely. And this 8 cancels. So 8 times 2 is 16. 8x times 2x, 16x. Now, all things left here is 2, so that's 2 times 3, which is 6. And then x times 17, 17x. All right, any problems with anything? Everybody good? All right, so now we want to get all of our terms with x on one side, all of our terms without x to the other side. So I'll go ahead and subtract 16x.
Okay, so how come you can't? So I think that's what I did wrong. I subtracted 6. Why can't?
You can do that. You can move either one of these 4 terms. It doesn't matter. So we can go your route. Subtract this 6.
If you do it the other way, you get a negative x and a negative number, which then you have to go back and do that way as well.
So you said a negative x and a negative number. What you mean? So you talking about if I
you
were to
subtract
subtract
16 and then you subtract 17, you would get negative 10 equals negative x, which then you have to divide by negative 1 to be positive again.
Yeah, you're right. And that'll be 10 equal to x. And then
Okay, that's exactly what I got.
Mhm.
But when I input the answer, it says it's wrong.
Now, did you put in, you put in x equal to 10?
Yeah.
Did you
It's
just,
exactly.
did you try putting in just 10?
I put 10 and then it says try again to find the restrictions. And then it made me take the skill builder. But that's
Okay.
exactly what I got.
Hold on. Let me take a look at something real quick because I didn't open up Math Lab, but.
I didn't have this problem on my homework.
Oh yeah?
No.
Let's see, 161.
I worked on this for like 2 hours yesterday. I was really, really upset. I just could not get it.
All right, hold on, I'm almost there. Make sure that's something missing. So we look at 1.2. And you said number 9.
Yes.
All right, so now the first one is actually about restrictions. So now you said you did answer the first one with and I'll show you guys what I see.
Were you answering the first part of the question? Because in the second half of the homework, it asks you what the variable can't be first. And I actually made that mistake on my first question.
Right.
So on mine it says are the value or values of the variable that makes the denomination 0.
Yeah.
And then it has x equals what? Simplify your answer, use a comma to separate answers as needed.
So that's what the question. So are you putting 10 right there?
Yes.
Yeah, that's where you see 10 is actually going to be for B. So if you look at my screen, that's where the solution is. So now
I
what
don't
they're
have
asking,
a B. Mine only shows A.
Yeah, it won't pop up until you answer A.
Okay, so I guess where does the 0 come in? How did
All right, so let me show you. Let me get back to the notes. So they're asking you about restrictions. They want to know when is your denominator going to be equal to 0? And so in other words, you would just take whatever's in the denominator, set it equal to 0. And then you were to divide this, x equal to 0. So you see that the only time that our denominator is going to be equal to 0 is when x is equal to 0. Because remember, I don't know if you remember when we had the lecture.
But is that, I do remember, and I didn't understand it. So is 0, you just put 0 just
Yeah,
because
because what it's
just
saying is that when x is
there's
equal
like
to
no
0,
actual formula behind it. It's just kind of like, hey, if you put a 0 there, it's always going to be 0.
well, no, it's like, okay, let's
It's not
say if my,
always 0.
yeah,
They
let's
just
say
want to
we
make
had
sure
this.
that you don't end up with a solution set that's like not possible. So let's say that like
Yeah.
the answer was 2 and 5, and then when you solved your equation, you got 5. That means that there are no solutions for this problem set.
Right. So let's say if this was our problem, and I want to know when is my equation going to have 0 in the denominator, I would set these equal to 0. Now, oh,
But isn't that a given? If it's 0, it's going to equal 0.
no, not when x. You're talking about when I plug in a value for x. So in other words,
Okay.
what would make this equal to 0 is when x is equal to -3.
Mhm.
So if I plug,
-5.
right, and this one would be when x is equal to -5. Because when you plug in x into that denominator, I'll get 0 in my denominator, which is negative. When I plug -5 into that denominator, I will get 0 in my denominator. So in other words, those two values cannot be my solution. Because if I were to get x equal to -3 as a solution, I'm actually going to get 0 in my denominator when I plug it back into my equation. So we're trying to figure out what values can we not use as solutions. In other words, our solution set is restricted to not using these values. So the one that you had up here, we cannot use 0 as a solution. So in other words, if this came out to x equal to 0 as a solution, that actually, I can't use that. So my answer would actually be no solution. Because if I were to use 0
Mhm.
and plug it in right here, I'm going to get 0 in my denominator.
Right.
And so that's what it's talking about as far as restrictions are concerned. Is there a value that you cannot use? Is there a value that will make me have 0 in my denominator?
Okay, so how do you determine what that value is that you cannot use?
So
I
you would
guess would
take
be
whatever's in your denominator, set
uh-huh.
them equal to 0 and solve it.
Okay.
So if you have x plus 3, if you set it equal to 0, and solve it, that'll be subtract 3 from both sides, and that'd be -3. So this -3 is a value I cannot use. So same thing with x plus 5. Set that equal to 0, solve for x. X equal to -5 is a value that I cannot use. So it's always about what is in your denominator. Set what's in your denominator equal to 0, and then solve for x. And those would be the values you cannot use as a part of your
So then
solution.
in the original problem, wouldn't it be -4, not 0 then? So, because I guess that's where I'm trying to fit, like,
Well, if you have 4x equal to 0, then you divide both sides by 4, and that's x equal to 0, because 0 divided by 4 is 0. So now if
where's
you
the
had
4x coming from up on the top though?
right
I'm
here,
confused.
your original problem. So remember, it's always about what is in your denominator. So you're talking about right here.
Okay.
So it's always whatever's in your denominator. If it has x, now 8, it don't matter because it doesn't have a variable involved. So you don't have to worry about that. But if you set 4x equal to 0 and solve, then that's how you would get 0.
What?
Okay.
Oh, I was like, what?
So
Oh, sorry, my cat wants to snuggle. She thinks class time is snuggle time. Say hello to the world. Say hello.
Definitely.
So, Ms. Dawn, was that good? You straight as far as that? So you're talking about what's in your
Keith, does
denominator.
that make sense?
You set
and I
each.
have a better understanding, I guess.
Okay.
I'm gonna struggle with that whole finding 0 and
Okay.
stuff,
So
but I'll maybe with practice I'll get it.
yeah, it always depended upon what is in your denominator originally. You set whatever's in your denominator to 0, solve it for x, and then that will be what you cannot use as a solution. Okay.
Did I get that question right that I put in the chat? I think I explained it to him correctly.
Let me see. What does it mean for all real numbers? All real numbers. Yep. And we're going to get into our next section.
Yeah, it's
But yeah.
1.4, isn't it?
Mm-hmm. So yep. We talk about all real numbers, mean you can use any real number as a solution and it will work out okay. So. All right. So I know somebody else said they had a question about a problem.
I think she left.
I was about to say, is she still here? All right. So anything else, anybody else before we close out?
So the stuff that we just covered today, that's just one chapter, right? Does it
one
get
section.
worse? One section, does it get worse? Like,
Well, I wouldn't say worse because, you talk about word
Yes.
problems. When we talk
I'm
about word problems.
legitimately concerned about failing right now
No, I
because
wouldn't do
everything
that.
in this section, I don't get any of it.
Yeah, I wouldn't do that.
So I'm gonna have to rewatch the class about 1,000 times.
Yeah, I wouldn't do that to yourself because you're talking about one section. Like I was mentioning, even when I put it on the test, I can't. It's not like the test is going to be flooded with this one section full of word problems. You know what I mean? Only put like 2 at the most 3. I think I put 2 on the test. But anyway, so it's not like what you see is going to be dominated. Like this, not like this whole class is going to be dominated by word problems. So there's only one section. And if you were able to do 1.2 and you were able to process that, then going into the next, other ones that don't have so many don't have word problems or don't have so many words, period. You probably go back into that same flow. 1.3 is almost like, you run and then jump.
Review.
Yeah, well, it's just like in the dynamic of trying to process information. It's almost like you're running. All of a sudden, you have to jump over a ditch, but then you go back to running. You know what I mean? Because that's like it's almost like a different kind of exercise because now you have all of these words that you have to process alongside with the numbers and the letters and all the stuff like that. So
Because the homework is technically still practice, did you want to like leave the chat open? Because I like to do the homework right after the class, and we could just leave this open and we could work through the homework together.
I can see how long it'll stay open. Yeah, I don't have a problem with that.
I'll stay here with you, Dawn, if you want.
So
All right, yeah.
So hold
I'm
on, guys.
lost.
Brandon with the low mic trying to speak for a second.
Brandon's just in the background talking shit about everybody because we can't hear him.
What you got, sir? Oh man, I can't hear you at all. You're not muted.
Bro, you need like headphones or like a mic or something.
All right, we setting up a GoFundMe for Brandon.
Yeah. You might want to try typing it in the chat because you're going all the way mute now. I don't know what's going on. But yeah.
I used to be a math tutor, so I can help as much as I can, I guess.
Okay, cool.
I mean, that was back in the day.
Matter of fact, I can go ahead and stop this recording. I don't want to make it too long.